Hey everyone, this is Dr. Clyde Letzum again with another explanation for a common physics principle. Today we'll be looking at free fall. So let's start with this. What is free fall? An object in free fall falls under the influence of gravity only with an acceleration of g, and we'll talk about what g is in a little bit. The distance an object falls, which is actually the displacement, y minus y0 during a period of time t, is given by the kinetic equation or kinematic equation, pardon me. Y is equal to y0 plus v sub 0 t times t plus 1/2 gt squared. So that's our kinematic equation that we can use in order to figure out what the displacement is of an object at a specific instant in time if it's under the situation or under the conditions that we consider to be free fall. All right, so now to expand on the equation a little bit more. So y again is the displacement from a reference point, and again we'll talk about the reference point. That's coming up in a little bit. So y again is a displacement from a reference point at the final time of interest. What we mean by the final time of interest is while we're doing an experiment, at the beginning of the experiment, that's the initial time of interest, and at the end of the experiment, that's the final time of interest. After that, we don't care what's going on. So again, y is displacement from the reference point at the final time of interest. Y sub 0 is the displacement from the reference point at the initial time of interest. V sub 0 from our kinematic equation is the initial velocity at the initial time of interest. T is actually the duration of the experiment, and when we say the duration of the experiment, that's from the initial time of interest as the experiment is being conducted to the final time of interest. And G, as I promised, we're going to talk about what that is the gravitational force or gravitational acceleration, and that is equal to 9.8 or negative 9.8 meters per second squared. All right, so now let's look at this reference point that we're talking about. So if we have a ball, and the ball is indicated by this blue circle here, if this ball is being dropped from some distance above the ground, okay, if we make the reference point, if we start to look at the entire experiment from the point of where the ball is being dropped, we will call that the reference point. And so we can draw an XY axis at that reference point. Okay. If this is the case, then we know that gravitational force is going to be pulling the ball downward, right? So that's what the red arrow here is indicating. And if this is the case, then our initial displacement from the reference point is going to be equal to 0 because the reference point is at the initial location of the ball. The final location of the ball, meaning the final time we care to even look at what's going on in the experiment, will be the height relative to the reference point. Again, y, which is that final time or final position, pardon me, is the final height relative to the reference point. So now, given a scenario like this, if we were to look at the kinematic equation that we started off with, okay, if an object is dropped from rest and our reference point is at the point where the ball is dropped, which is what we had in the previous slide, then we can say this. We can say that v sub 0 is equal to 0 because remember, it's starting from rest. So that means the initial velocity is equal to 0. The initial position in this case, since the reference point was on the ball, okay, then that means our initial position, all right, is going to be equal to 0. Now this makes our equation then equal to the following. So you'll notice that this term here in our equation actually goes to 0 as we indicated up here. And because v sub 0 is equal to 0, then that makes this term go to 0, which leaves us with just an equation of y is equal to half gt squared. Okay, so now what if we actually move the reference point to a different point? Okay, so in other words, we're thinking about we're looking at the experiment from a different point and we're considering how everything is relative to that point. So to give you an example, our reference point in this case is on the ground. So this could be someone standing on the ground and a ball falling towards the ground in this case. If this is the case, then what would happen is our reference point would be at the ground, so we'll draw our XY axis at the ground. The ball is still falling, and of course, again, we have a gravitational force pulling the ball towards the ground. In this case here, all right, in this case, y will be equal to 0 at our reference point. So down here, y is equal to 0. Now our initial position, okay, the displacement from the reference point, our initial position, is actually the height of the ball from that reference point, okay? So now if we have a situation where we're looking at the experiment from this point of view, then the same equation from our free fall, or our kinematic equation from our free fall there, what would happen is, again, our initial velocity is equal to 0, because again, the ball is not moving. Nothing has changed with that. However, though, in this case, remember our initial position, the displacement, or how far it was away from our reference point, actually has a value. Okay, so we cannot cancel that term out. However, though, what happens here is our final position of the ball. Okay, how far it's displaced at the end of the experiment, if we're considering the end of the experiment when the ball hits the ground, what happens is that final position is going to be equal to 0. So if that's the case, then what happens is this term goes to 0 and this term goes to 0, which leaves us with 0 minus y sub 0 plus 1/2 gt squared. Okay, now if we subtract y sub 0 from both sides, what we end up with is negative y sub 0 is equal to 1/2 gt squared. And we can use that in order to, for instance, find the position of the ball initially by using that equation. Now both equations are valid again. It's all dependent upon how you're observing the experiment. What do you call your reference point? Okay. So what I want to do from here now is I want to continue with an example. This is one that's very similar to one that's in my lab. And in this case, the students are doing an experiment where they're going to try to calculate what gravity is based off of them doing a free fall experiment. So using the equation that we had before, the equations that we had before, I'm going to look at it as if, so we're going to start off with this first equation here, as if the reference point is at the ball. Okay? And if that's the case, then we have y, remember we had, pardon me, y is equal to 1/2 gt squared. So in this case, then we multiply both sides by 2 because we want to figure out what the experimental gravity is, right? So we want to isolate g by itself. So we multiply both sides by 2. That gets rid of the half over here because 2 times 1/2 is equal to 1. 1 times anything is the anything, right? And so once we've done that, we divide both sides by t squared, which leaves us with this g here, which allows us to find gravity. And this would be our experimental gravity. So it's 2 times y divided by t squared is equal to our experimental gravity in this situation. Now from here, you can take this experimental gravity from your data that you collected in the lab, and then you can compare that against our established experimental gravity, which we talked about before, and I'll slide back a few slides here. Remember, which is equal to negative 9.8 meters per second square. Okay, so this is the way that we would approach a free fall experiment using our kinematic equation, and then how we would look at the experiment from 2 different point of views. Both are correct. It's just a matter of how you look at the experiment, and how you would calculate your experimental gravity from that information in order to be able to compare it against what is our theoretical or our accepted value for gravity. All right. So again, this was a discussion on free fall. My name is Dr. Clyde Letsom. If you want more information on me, you can find more information at my website. You can also check out other pictures and other videos on physics on my YouTube channel. If you like what you see, please do like, and please do subscribe to my channel.